Hi, this is Mirvala Sadrafshari. I'm going to talk about an unsupervised machine learning algorithm, which is named density-based spatial clustering of the application with the noise, or DBSCAN. And we will see about this topic. Okay, first of all, we will see about what density-based clustering is, and then we will go through the details of DBSCAN algorithm. Okay, I will just turn off my camera and continue to explain and talk about DBSCAN. Okay, now let's go and see what is the density-based clustering. Density-based clustering is a kind of algorithm that's based on the use of this density of the cases and points in our data set to assign each of these points to a cluster. And these clusters in a data set will show regions of the regions with the high density and the low density. This is the work that this density-based clustering will do to split low and high density regions. This density-based clustering has two algorithms, DBSCAN and optics, which I will talk about DBSCAN only today. Let's see what's the goal. What's the goal of this clustering? It's just to divide the data to different clusters to separate them as a groups with the structures. Let's dig in. First of all, we want to see the similar methods, just like k-mean, hierarchical clustering, and DBSCAN. You can see here the results of these three methods, and you can see the DBSCAN can perform well rather than the others in this dataset, and it can show better performance. As you see here, even a sinusoid wave can be recognized by DBSCAN, but not in others because they have different clusters. Let's see the similar method, just like k-means, performance in different datasets with DBSCAN. As you see here, k-mean shows different performance in different data with maybe different case, 3 or 2, but in DBSCAN we have almost good performance, acceptable one to each of these data sets. Okay, let's see what DBSCAN is and how it works. First of all, with some definitions, just like parameters, some kind of points and concepts, we will see them. The first parameter is epsilon. Epsilon is a metric that we at most cases uses as a Euclidean distance. When we just select a random point, just like this red one, we just can search around this radius, epsilon radius area, just like this circle from this red point. And we can count the number of points that are located inside this area. Minimum points. Minimum points is the number of points at least they need to locate it inside this area to call this red point as a core point. So what is the core point? Core point is a point that has at least minimum number of points inside its epsilon radius area, just like this circle. If you have 3 points, we have a core point inside this area. The border points are the points that are not core point, but they are inside epsilon neighborhood of a core point. And the last one is the noise point. These noise points are not core points, and they are not in epsilon neighborhood of any core point. These concepts, just like directly density reachable, we can say P is directly density reachable from Q, which means Q is core point and P is inside the epsilon neighborhood of Q. Density reachable is kind of a chain that P and Q are connected to each other, means reachable to each other. So P and Q are density reachable to each other if, for example, P is density reachable from Q, because there are some core points here. And density connected is a different concept, that P and Q are density connected to each other when there is a kind of this X point, which is in the between of these two density reachable sides. X is density reachable to each other, these two ports, and these P and Q are density connected to each other. Okay, let's see how this DBSCAN algorithm works. Just for your information, I will just briefly describe the algorithm works, and then we will see this video. First of all, we will find all core points in our dataset. As you see here, this is red point. These red points are core points. Then we will pick a random core point and create our first cluster. Our first cluster will form by this first core point, the green point. Then we will just see other core points in the epsilon neighborhood of that core point, and just they will join in the first cluster. And after that, there are some non-core points close to our cluster. Is here, just they are kind of border points, and they will join to our cluster later. And now there have some other maybe clusters, second cluster. These are the blue ones that are second cluster and core points. These are core points, border points around them, and they join to second cluster as well as the previous one. And these black ones, which are near non-core point and border point, they are called outlier or noise points, which are located far from these clusters. Okay, now let's see just an example here. As you see, this is the raw original points. These are core points, borders, and noise points, and this is the output of the clustering of DBSCAN. DBSCAN usage, let me explain about this Netflix. There, for example, if someone watched the movie of Shameless, Netflix will consider the other customers watch the Shameless movie and the other movies, and will suggest the other movies for who just watched the Shameless movie. Let's see what is the advantage and disadvantage of DBSCAN. The advantage of this DBSCAN can handle all shapes of datasets, and there is no predefined clusters. We don't want to define any cluster before starting this algorithm. Just it's not like k-means, because k-means need predefined clusters. And some other advantage, just easy to implement. There are few parameters to tune, and these unaffected noise points. The disadvantage, this algorithm is not deterministic. DBSCAN cannot cluster different densities as well as the other algorithms, but it also working well for different shapes of datasets, and it's not good for high dimensionality datasets. Thanks for your attention. This is my references that I used, and I appreciate your attention. Thanks.